To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to continue with the paper 2 part B of GCE O-Level 2021 examination paper. So in the previous chapters we started discussing part A, the first 4 questions, and then I started part B and I discussed the 5th and 6th questions with you. Now this is question number 7. So when you see the ray diagram, like I told you all know it's a physics related question. Question number 7, A part. The diagram shows how a ray of light coming through air falls on a block of glass. So that means, so there is air, then there is a block of glass. That means 2 different media. Normally, you all know light, if it is one media, if it strikes on a surface and bounces back into the same medium, then it is reflection. But when light travels from one medium into another medium, the path of light changes. So there it is refraction. So here, since they say air and glass, and when you look at the diagram also, you all know this is related to refraction of light. So then, that ray of light travels through the glass block and emerges into the air again. So that you know how a glass block refracts light. Refraction of light through glass block, we have seen that in the lab also. So you are familiar with that. If you look at the diagram, they have shown the glass block, then they have shown air, then the ray. So you all know this is the incident ray, and this line that is perpendicular to the interface is the normal line or normal, and the angle between the incident ray and the normal is 30 degrees. So that is the incident angle. Then there is the interface here, air and glass. So there will be refraction. You all know, students. Now air and glass, when you compare, it depends on the speed of light. Now speed of light is fast in air. So that means air is a rare medium. Whereas glass, the speed of light is less. So we call that as a dense medium. So glass block is dense. Air is rare, glass is dense. So when light travels from a rare medium into a dense medium, it deviates from its path, it refracts towards the normal. So you know that it refracts towards the normal. Then what happens? Again there is an interface, glass block and air. There, of course, from a dense medium, it is coming into rare medium. Again, there will be a refraction at this interface, and the refraction will be away from the normal. So you will see a incident ray, a refracted ray, and an emergent ray. So 2 points where there is refraction. Now if we look at the first question, you all know, draw the rough sketch of the complete path of the light ray on your answer script. So that is what you need to do. So here, if I redraw the structure there. So here we have the block of glass there. Then if we draw the light ray, here this is the light ray, they have already shown to us. This is the normal and the angle is marked as 30 degrees. So draw the rough sketch of the complete path of the light ray on your answer script. Now I'll just use different colors so that it's easy for you all to observe it. So here you will see, instead of the light ray going this way, what will happen is it will refract towards the normal. And that angle will be the angle of refraction, R. So this is going to be the refracted ray. ray. Here this is the incident ray. And this is the angle of incidence. So here of course they have told you all to show the path of the light ray. I am giving you a complete answer where I am labeling all these parts. So this is the normal. Then refracted ray, like I told you all, there will be another refraction. Now at this point here, again there is a normal. But here you all know students, the refraction, it happens away from the normal. Why? This is the refracted ray. At this point, this is the glass air. But what will happen is, the light ray is going from dense medium to rare medium. So because of that, it will refract from the normal. So here students, if you properly measure and draw. Here of course I did not measure anything. When you measure and draw, you will see this ray, that is the incident ray, and this ray, which is the emergent ray, will be parallel to each other. This is angle of emergence. So angle of incidence, this is the refracted ray where R is the angle of refraction and E is the angle of emergence. So this is the path of the refracted ray. Initially it refracts at this point, refracts towards the normal, again away from the normal. And these two, if you see, they will be parallel to each other. Is that okay? Then you all know students, according to refraction, there are two laws. Laws of refraction, the incident ray, normal, and the refracted ray, they all lie in the same plane. Then sine I, that is the incident angle, sine value of the incident angle, with the ratio divided by the sine value of the refractive angle. Sine I over sine R is a constant, and that constant is known as the refractive index. And this refractive index depends on the media where the refraction takes place. So here of course this is air, this is glass, again there is air. So this refractive index is a constant value between air and glass. But when you consider this point, it is from glass to air. Then the refractive index will be the inverse value. Is that clear, students? From this also, you should be able to understand that this angle and this angle are equal, whereas this angle and this angle will be equal. Mathematically also, you can derive that because these two rays are parallel to each other. Then you all can understand this angle is equal to angle of emergence. Is that okay? So this is how the refraction occurs. Draw the rough sketch of the complete path of the light ray on your answer script. So you need to draw this sketch, but here I have shown all the additional information as well. You have to draw the path only. If you show this, that is more than enough. Is that clear, student? So with that, I'll move on to the next part. Second one, in the sketch, mark the angle of refraction R relevant to the first refraction of the ray. So since they have told to mark the angle of refraction, I will do that again here. Again, there is the normal. It refracts away from it. So here you need to mark the angle of refraction. So this is what you need to draw. In the first diagram also, you show the refracted ray, emergent ray. You make sure these two look parallel. Here, of course, I didn't use a ruler or I did not measure. But when you draw it with the ruler, using the ruler and all that, you will see these two rays are parallel to each other. So here we are supposed to mark the R, refraction, angle of refraction relevant to the first refraction of the ray. So that I have marked here. You will be doing all this in the same diagram. You don't have to do it again and again. You will be doing it in the same diagram. Here, of course, I have done it for the second time because there I have marked all the information. So, in your diagram, you will have these two rays. Then you would have marked R. With that, I'll move on to the next question. Here, write the equation which shows the relationship between the angle of incidence and angle of refraction. Consider that the refractive index of glass with respect to air is N. So, always glass with respect to air. From what medium to what medium? So, light will travel from air to glass. So, in refractive index of glass with respect to air is N. Normally, we use the symbol neta and there we need to specify air to glass. So, here also when you write N air to glass, so then it has to be sin I over sin R. But in the diagram, they have given the value for I. That is 30 degrees angle. So, that means this will be equal to sin 30 divided by sin R. If we go back, here you can see this is 30 degrees, this is R. So, sin I over sin R, that is refractive index. So, you can write air in glass equals sin 30 degrees divided by sin R. You can skip this part as well. Here I have shown you the explanation. You can leave this and directly write it like that. So, here you can give the answer this way. N air to glass equals sin 30 divided by sin R. That is the answer. Here I have shown you how we get it. Is that clear, student? So, there. Fourth one, what is the value of the angle of emergence of the light ray? So, like I told you all, if we go back to this diagram, now this ray and this ray are parallel. So, because they are parallel, if you consider the emergent angle, this one, angle of emergence, in the previous diagram I have written everything. So, this 30 degrees and this emergent angle of emergence are equal because these two rays are parallel. Is that clear, students? So, what is the value of the angle of emergence of the light ray? It is going to be 30 degrees. Is that clear, students? So, that is how refraction occurs. With that, I'll move on to the next part. This is part 5 of the question. The following diagram indicates how a light ray traveling from a denser medium to a rarer medium falls on the interface. So, if you look at the diagram, now here it is the denser medium. So, this is the incident ray and the angle of incidence is theta. Then you have the rarer medium, they have drawn the normal. But they have not shown the refracted ray or the angle of refraction. So, if we look at the question, here but you all know, students, when it is from denser medium to rare medium, it refracts away from the normal. That is something you can remember. So, A part, what is the path of the refracted ray when the angle of incidence in the denser medium is equal to the critical angle? So, here if we consider this concept just for you all to understand, now you can remember, students, normally when we have a medium like that, a ray going that way, I'll use a different color. So, here if it is from the denser medium to the rarer medium, it refracts away from the normal. So, this is dense, rare. And further, if we increase the, now here if we keep on increasing the angle of incidence, at one point what will happen is the refracted ray will go along the interface. So at this point, this particular angle is written as C, critical angle. Critical angle. Now after the critical angle, if we increase the value, let's say we will take this as theta 1, this is critical angle, then if you increase the angle of incidence, then what will happen is it will not refract, instead it will reflect within the denser medium. So this is the denser medium. Dense rare. So here if we take this as theta 2, that is greater than critical angle. It will reflect with the same theta 2. This is known as total internal reflection. So you all know that. Total internal reflection. So here theta 1 is less, critical angle is greater, and theta 2 is greater than critical angle. Theta 1, it is refraction away from the normal. When it is critical angle, refraction, but this angle is 90 degrees. 90 degrees. Then after that, if you increase the angle of incidence further, there will be no refraction. Instead, there is total internal reflection. So this is the concept of total internal reflection. You all are familiar with this. Now if we answer the question given here. What is the path of a refracted ray when the angle of incidence in the denser medium is equal to the critical angle? Then of course, again you have to copy this diagram and you have to show the path of the refracted ray. So we have the medium like that. This is dense. This is rare. So you have the angle, then it will go along the interface. This is theta. This will be 90 degrees. So the ray will go along the interface. Is that clear? What is the path of the refracted ray when the angle of incidence in the denser medium is equal to the critical angle? So like this, you need to show it in the diagram. Is that okay, student? So with that, I'll move on to the next part. Then the fifth part of the question. The following diagram indicates how a light ray traveling from a denser medium to a rare medium falls on the interface. That is the same question, same diagram. Part B. By what name is the phenomenon happening known when the angle of incidence in the denser medium is greater than the critical angle? So I explained to you all in the previous question itself, when the angle of incidence is greater than the critical angle, the light ray does not refract, instead it reflects. So here we saw that happening. In this instance, we saw that happening, and this particular concept is known as total internal reflection. That is what you need to write here. By what name? So there we have to say total internal reflection. Total internal reflection. Is that okay, student? So with that, I'll move on to the next part. The same introduction and the diagram is given. C part of the question. Write 2 examples for instances where the phenomenon in B above is made use of. So, using total internal reflection. You all can remember, students, the optical fibers. Optical fibers are used in communication, in network cable connections. There is total internal reflection taking place. That is very useful. There the transmission of data occurs very fast, as well as loss of data and loss of signal is the minimum, because it is transmitted by total internal reflection. So you can write optical fibers as one answer. Then you all can say these optical fibers are used in communication, telecommunication, fibers in telecommunication, then internet connections, that is the data cables. Then you all know, students, now this particular concept, that is total internal reflection, is used in optical fibers which are used in endoscopy. Endoscopes use optical fibers. There is total internal reflection. So there is endoscopy. Endoscopy is a medical technique where the fiber is sent into the body of a person for either observation to determine the disease or the condition of a person, or for certain procedures. For that, we use endoscopy. There, optical fibers are used, where there is total internal reflection of light taking place. So, in optical fibers in telecommunication, internet connections, then endoscopy, we use total internal reflection. Is that clear, students? And also in certain decorations. In decorations also, you all have seen some of these ornaments where you have those fibers and the end of the fibers are glowing. So that even on stage decor, there we use total internal reflection. So all these are possible answers. You only need to write 2 examples. You can write any 2 examples. So I have given you these answers: optical fibers, fibers in telecommunication, internet connections, endoscopy, decorations, and also you all are familiar with binoculars, students. Now we have discussed how prisms actually change the path of light, where there is total internal reflection taking place, and the path of light is changed by 90 degrees. So these prisms are used in binoculars. So that is another example where we use total internal reflection. So here we have to consider that as well. Total internal reflection or in prismic binoculars, or we can say prismic binoculars. So in that also there is total internal reflection taking place. Is that okay, students? So those are the different examples. You need to write only 2 examples. With that, I will move on to the next part of the question. Here this is part B. Water of mass 1 kilogram is contained in an electric kettle used in a house. So there is 1 kilogram of water in an electric kettle used in a house. First part, what is the amount of heat required to raise the temperature of 1 kilogram of water from 20 degrees to 100 degrees Celsius? So 1 kilogram of water, 20 degrees to 100 degrees Celsius. The specific heat capacity of water is given as 4200 joule per kilogram per degrees Celsius. So you have the water at 20 degrees Celsius. By providing heat, the temperature is raised to 100 degrees Celsius. The mass of water is 1 kilogram. Then specific heat capacity. What is specific heat capacity? The heat that should be provided to increase the temperature of 1 kilogram of a substance by 1 Kelvin or 1 degree Celsius here. So that is 4200 for water. So then we can calculate the heat that was required. Heat is Q is equal to mc theta, where m is the mass of the substance, c specific heat capacity, and theta is the change in temperature. Q is the heat required. If we substitute the values, the mass is 1 kilogram. Here also, the units are optional, students. You can substitute with the units or without the units, but you have to make sure that they are all in the standard unit. So, kilogram, no problem. Then, specific heat capacity 4200 joule per kilogram per degrees Celsius into theta. Theta is what? The maximum temperature, 100 minus 20 degrees Celsius. So there, if you calculate 1 into 4200 into 100 minus 20, 80, kilogram minus 1 cancels off, degree Celsius minus 1 degree Celsius cancel off. So you get the units in joules. So that is equal to, if you do the calculation here, 4200 into 80, 16, 33. So 336,000 joules. This is equal to 336,000 joules. You can also write this in kilojoules. 1000 joules is equal to 1 kilojoules. So 336 kilojoules. Is that clear, students? So that is the amount of heat. What is the amount of heat required to raise the temperature of 1 kilogram of water from 20 degrees Celsius to 100 degrees Celsius. So when you do this, you write the equation, substitute the values. Like I said, writing the units while substituting is not compulsory, but the values have to be given correctly. But final answer, you have to write the unit. You can give the answer in joules or kilojoules. That is up to you all. So when you do all that only, you will get the full mark. Now, if this answer consists of 3 marks, you will get 1 mark for the equation, then 1 mark for substitution, and 1 mark for the final answer with the correct unit, if there is a unit. So here, of course, joules, you have to write it with the unit. Is that clear, students? So with that, I'll move on to the next part. Second part of the question, find the amount of heat absorbed by the kettle when the temperature of the water in the kettle was increased from 20 degrees Celsius to 100 degrees Celsius. So when water, the temperature increased from 20 to 100, we will consider that the kettle also goes from 20 to 100 degrees Celsius. The change in temperature is considered same. Here, heat capacity of the kettle is 160 joule per degrees Celsius. So here they have given the heat capacity. What is the difference? Heat capacity is the amount of heat required to increase the temperature of a substance by 1 degree Celsius or 1 Kelvin. So here we don't need to consider the mass, and the mass of the kettle is not given also. So then we can calculate the heat Q as C theta. C is heat capacity. So what is that? Heat capacity is 160 joule per degree Celsius into theta we already calculated as 80 degrees Celsius. So directly I can multiply. So then of course you will get the answer 160 into 80. So we have 0, 0, 8, 12. 12,800 joules. Even this you can write it as 12.8 kilojoules. So here we use capital C. Heat capacity, capital C. Specific heat capacity, simple C. So there we got the answer. Here also we got the answer in joules. 12,800 joules or 12.8 kilojoules. Is that clear, student? So with that, I'll move on to the next part of the question. Like I told you all, here also you have to substitute correctly and calculate the final answer. Is that clear? Then the next part. Part 3. The power of the heating coil used to heat the kettle is 1000 watts. So when you say power, you all know. What is power? The amount of heat energy or amount of energy used in a unit time. So you can remember that. Then what is the time taken to heat the water in the kettle from 20 degrees Celsius to 100 degrees Celsius? What is the time taken? Now power of coil is given to you. Power you all can remember is VI. But energy is equal to power into time. So here we know the energy. We have already calculated the energy. We know the power. We need to find the time. But here also you need to consider, students, the energy required is equal to energy for water plus energy for kettle. Because when you provide heat energy, initially the kettle absorbs, then the water. So both of them go from 20 degrees Celsius to 100 degrees Celsius. So we calculated both the values. If I go back, 336,000 joules and 12,800 joules. 336,000 joules plus 12,800 joules. So if you add them together, 348,800 joules. That is the amount of energy that was required. Then, power of the kettle is given. Power equals, or we can say, we know the equation. Energy equals power into time. E equals PT. That is the equation we know. So, in that we know the energy. That is 348,800 joules. Power is given to us as watts into time. Now, here we need to find the time. Watts you know is joule second. So, when you rearrange, before we do that, if we substitute. Now, this is again for you all to understand 1000 joule per second into time. So, if you rearrange, you will get time is equal to 348,800 joules divided by 1000 joule per second. So, there you will get the answers 348.8 second. So here joule and joule cancels off. Then you finally end up with the unit seconds. 348.8 seconds. Is that clear, students? So that is the time taken for the kettle containing 1 kilogram of water to be heated from 20 degrees Celsius to 100 degrees Celsius. if the power of the kettle is 1000 watts. That is what is given here. The power, the heating coil used to heat the kettle is 1000 watts. So we calculated the energy before that. You need to add the energy needed to heat water as well as the kettle. So when you add them together, you get the answer as 348,800 joules. Then you know the equation, energy equals power into time. In that, if you substitute and rearrange, time is equal to 348,800 joules divided by 1000 joule per second. You get the answer as 348.8 seconds. Is that okay, student? So with that, I'll move on to the next part of the question. Fourth part of the question. The following measures have been taken to prevent the loss of heat from the kettle to the outer environment. A. Closing the kettle with a lid. And B. Polishing the outer surface of the kettle well. State the method of heat transfer controlled by each of the above measures. So there are two measures. So before we answer the question, now you all know, students, there are three ways in which heat is transferred from one place to the other. Through solids, it is by conduction. So there you all know, when you provide heat to one end of the solid, due to the vibration of the constituent particles, heat is transmitted from one end to the other. So there we call it conduction of heat. But in gases as well as liquids, it is convection. There what happens when you provide heat, the particles become hot and the hot particles tend to rise up. At the same time, the cooler particles come down. So this particular movement of hot particles moving up is known as convectional current or convection current. So that process of transferring heat is known as convection. This happens in liquids and gases. So conduction in solid, convection in liquid and gases. Now these are all in different media where there are particles. But if there is heat transferred through vacuum or space, then it is in the form of electromagnetic radiation. So that process is known as radiation. To prevent this, you can use different methods. Now here you can see closing the kettle with a lid. Now if we have a kettle, I'll just draw it as a container like that. We have the kettle. If you close it with the lid. Now this lid, normally if it is conduction, it will be from the walls and through all the sides. But if it is only the top, it is due to convection. So this is convection process. Lid prevents the process of heat loss by convection. You are polishing the surface. If this surface becomes shiny, then what will happen? The radiation, the heat waves will be reflected back into the surface, into the substance contained in the flask. So there it is preventing heat loss by radiation. You have to remember that. And the shiny surface, polishing the outer surface of the kettle well, it prevents the heat loss by radiation. So that is what you need to write here. So A, it is convection, and B is radiation. Now these are methods used in thermos flask also. Thermos flasks that are used to store substances, liquids which are hot, or you can store liquids that are cool to retain their temperature. So there these methods are utilized. Is that clear, students? So with that, I have actually completed question number 7. So here again 20 marks. Now I have been telling you all each question is out of 20 marks. So with that, I'll move on to the next question, that is question number 8. So now question number 8. In that A part, some phenomena faced and identified by a farmer maintaining a mixed crop cultivation are given below. So here some phenomena faced and identified by a farmer maintaining a mixed crop cultivation are given below. You all know the meaning of mixed crop cultivation, students. So if there is a plot of land, the land is divided into different areas, and in each area there are different types of crops cultivated. That is known as mixed crop cultivation. Or else you can have a plot of land where there are different lines of different crops. So like that also it is possible. Or it can be in a circular manner. In the center you can have a certain type of plant, around it in different circles there can be different types of plants. Either way, in a certain plot of land there are different, more than one type of crops growing in it at the same time. So that is what we consider as mixed crop cultivation. You all know the advantages of this. Now, some plants use certain minerals in higher amount, whereas some plants provide minerals to the soil. For example, the legume plants. In them, the rhizobium bacteria lives as a symbiotic organism and that fixes nitrogen. Because of that, the soil where the legume plants grow, they are rich in nitrogen. So, like that, there are different plants. Some use up minerals more and some provide minerals to the soil. So, that is the reason to maintain the nature of the soil or the mineral content of the fertility of the soil. They use this mixed crop cultivation. So, you are familiar with this concept. Then, answer the questions asked on them. So, part 1, the passion fruit cultivation produces flowers but does not set fruits. So, when you say produces flowers but does not set fruits, there you all know it is related to reproduction. So, if you take a plant, students, the angiosperm, those are the flowering plants, you all know the flowers are the reproductive structure. That is the sexual reproductive structure of a plant is the flower. Now, in the flower, there is the gynosium, that is the female reproductive structure, which is composed of the stigma, style and oval. At the same time, there is the androsium. Androsium is the anther and filament together, which are known as stamens. So, these are the male reproductive structures. Now, inside the anther, there is the pollens produced, and when there are mature pollens, usually the anther breaks and the pollens are given out. So, there the pollen, mature pollen from a flower has to come and fall onto the mature stigma of a female reproductive structure. And that process, depositing of a mature pollen on the stigma of a flower is known as pollination. So, you all know there are two types of pollination. One is self-pollination, the other one is cross-pollination. If it is self-pollination, pollen of one flower falls on the stigma of the same flower. So, there is only one flower. Because of that, there is no variation possible. Therefore, normally plants, what they do is they prefer to carry out cross-pollination. So, because of that, they show adaptations to prevent self-pollination and do cross-pollination. And when we say cross-pollination, the pollens from one flower fall on the stigma of another flower. So, there should be two flowers involved. So, that gives rise to better qualities. It helps in evolution. So, mostly plants prefer cross-pollination. So, now here, the observation says the passion fruit cultivation produces flowers but does not set fruits. So, that means, now you all know the pollination has to occur. After pollination occurs, the pollen has to grow into the pollen tube, and through the pollen tube, the gametes have to travel towards the ovary, and there the ovules have to get fertilized. So, thereafter, the ovary will become the fruit. So, for this to happen, you all know, students, there are two types of flowers. If they have both the androsium and the gynosium, we call them as bisexual flowers. Whereas if there is only either the female reproductive structure or the male reproductive structure, they are unisexual flowers. Now, passion fruit, you all know, is a bisexual flower. For the pollination to happen, the pollens from the androsium have to fall on the mature stigma of the gynosium. If that does not happen, then of course there will be no fruits. So based on that, now if we look at the question. Therefore, the flowers need to be artificially pollinated. So what we guessed it correct. It has to be artificially pollinated. How are the passion fruit flowers artificially pollinated? Now, when you say artificially pollinated, normally all know students, there are different agents of pollination. Now, the animals or the insects are there, then there is the wind and there is water. So, these are different methods of pollination or agents of pollination. If that doesn't happen, then there is artificial pollination. How is that carried out? You collect the pollens from the male reproductive structure, that is the androsium, and they have to be deposited on the stigma of the female reproductive structure, that is the gynosium. How do we collect and deposit the pollens? Either you can use your fingertips, or you can use a brush, or tweezers can be used. So, one of the methods can be employed to deposit the pollens from the male reproductive structure on the stigma of the female reproductive structure. So, that is what you need to write as the answer here. So, if we say the pollens are collected from the pollen sacs and deposited on the stigma of the female reproductive structure of the flower using the fingertip or a paint brush. So that is what happens here. The pollens are collected from the pollen sacs and deposited on the stigma of the female reproductive structure of the flower using the fingertip or paint brush. Now this is the answer for this question. But the thing is, students, for this answer, all the students were given free mark. That is 1 free mark. The reason is this. Although this is there in your textbook, the grade 10, unit 14 lesson, that is reproduction, sexual reproduction of plants, but this particular part is contained in the extra knowledge component. That is how artificial pollination is carried out, is part of the extra knowledge component. Normally, all are not given questions from the extra knowledge component. Since this was from that, the students were given free mark. Whether they wrote the answer or not, they were given a free mark. So, here 1 mark was given. 1 mark. So, you have to remember that. Normally, they do not ask questions from the extra knowledge component. So, that is the reason everyone was given 1 mark. Is that clear, students? So, with that, I'll move on to the next part of the question. So, here, the second part, cocoyam, that is gahala or shembu. Plants grow again after a certain period of time following the death of their aerial parts. So, these are yams. You all know how they grow. Their reproductive structure, you all are familiar with that, are underground stems. We'll read the question first. What is the term used to describe this process by which the cocoyam plants ensure their survival? So, here students, you all can remember, now there is the underground stem. Now, if you take the normal plant, you have the aerial parts that is above the ground and there are parts under the ground. Normally, the stem is a structure that grows it's an aerial part. It grows above the soil. But there are some underground stems which grow under the surface of the soil. So, you are familiar with that. Usually, they store food and they help to pass the dormancy period and to survive during the adverse climatic conditions. And also they act as vegetative reproductive structures. And based on their morphological structure, that is their external features, there are 4 types of underground stems. So if you consider them, there is the underground stem that grows horizontally like that. You are familiar with this. This is the rhizome. Now, normally ginger, turmeric, these are all rhizomes. Now, from this rhizome, there is the part that grows out of the soil, that is the aerial part. Then there is the second structure that is known as the comb. You are familiar with that also, combs. Combs are different because they grow vertically like this. Cocoa yam, taro yam, elephant foot yam, these are all different types of combs. Now, when you look at the comb structure, from here you get the aerial parts there. From this is the underground stem. Above that, you have the aerial part. Then we have the third structure that you are familiar with, the bulbs. Now, bulb also has a stem like that, underground stem with the roots there. Then we have the scale leaves. Now, onions are an example of bulbs. You have the scale leaves that store food and the rest of the plant. That is also something that you know. Onion, leeks, these are all bulbs. Then we have the fourth structure where you have the underground stem that branches out, and at the end of the branch you have the food storage, that is the stem tubers. Now these are 4 different types of underground stem: the rhizome, comb, bulb and stem tubers. Now normally they store food. That is why we use all these as vegetables or food substances for us. People use them for cooking. So you are familiar with these. Now what happens is they store food, they have the aerial parts. Now let's say when the environment condition is not suitable for plant growth, then what happens is these aerial parts are lost. The aerial parts are lost from the plant, but these underground stems, they survive. They have food storage, no? So they survive until that adverse climatic condition changes. So that period where they survive under the soil is known as the dormancy period. So that is also a function of these underground stems. Like I told you all, they store food, they help to survive through the dormancy period during adverse climatic conditions, and also they are vegetative reproductive structures. Now you can take these bulbs and replant them. You can take the comb or rhizome or stem tubers and you can replant them. So that is how these underground stems work. Is that clear, students? Or the underground stems are. Now if we look at the question, here you can see, if I read the question again, cocoyam plants grow again after a certain period of time following the death of their aerial part. So that is what I said. The aerial parts are lost or they die, and then what happens is they survive that particular period. What is the term used to describe this process by which the cocoyam plants ensure their survival? So there you need to specify 2 terms. One is you have to say about the dormancy period, and also that is during adverse climatic condition. So the main thing is that you have to say dormancy period. So this is surviving the dormancy period during adverse climatic conditions. So that is very important, students. You have to specify the word, the dormancy period or dormant period. Is that clear? So during that time, the aerial parts are lost, only the underground stem survives. So, and it helps the survival of that particular plant. That is what we need to write here. So with that, students, I'll move on to the next question. In the farmland, one bush of banana trees gives a greater yield. The plants in that bush are highly resistant to diseases. Name an artificial vegetative propagation method suitable to obtain a large number of banana plants with those traits at once. So here you need to obtain a large number of banana plants with those traits at once. So you have to look at the question carefully. Now this you can understand is related to artificial vegetative propagation methods. So there are different methods of artificial vegetative propagation. One is stem cuttings, where you cut a stem and you grow it into a new plant. Then there is the grafting method, where there is one plant grafted with another plant. It can be either twig grafting or the bud graft. So there you have the stock plant that has the root system and the scion, that is the new plant brought in. So that is grafting. Then we have layering. When the twig is connected to the mother plant itself, roots are formed on it and then the twig is replanted as a new plant. That is layering. So there also we have aerial layering and ground layering. Then you are familiar with the tissue culture. In tissue culture, you can remember, students, a tiny piece of tissue, say a piece of leaf, can be used to produce a very large number of plants in a very short period of time and a large number in a small space. So that is tissue culture. So here the question is, obtain a large number of banana plants with those traits. They are highly resistant to diseases. So that is a good trait. So to get that trait, you need to get the same type of plants. So it's easier to carry out tissue culture. Large number of plants with traits at once. At a time, you need a large number of plants. So it has to be tissue culture. Tissue culture. Is that okay, student? So with that, I'll move on to the next part. Now here, the fourth one. The farmer intends to use a wood apple plant growing in the farmland as the stock and graft an orange to it. So he is using two different plants, a wood apple plant as the stock. So you all know, if it is a stock, the root system has to be very strong. It should be resistant to pests and pathogens, and also it should be resistant to adverse environment conditions. At the same time, the orange twig becomes the scion. So the properties of the scion, the fruit, orange fruit and all that, they have to have good properties. So here the technique is grafting. I mentioned this to you. State two characteristics of the wood apple plant which would have caused its selection as the stock. Why do you select the wood apple plant as the stock? Like I mentioned, it should have a very strong root system. That is one. It has a strong root system. Then what can you say? It can withstand pest, or it is resistant to pest and diseases. It is resistant to pests and diseases. Also we can say it can withstand adverse environment conditions. It can withstand adverse environment condition. And also you all know students, this should be a stalk that should have a uniform growth. It should show a uniform growth. It should show uniform growth. So these are different reasons why the wood apple plant would have been selected as the stock plant. So here you need to write two reasons, two characteristics of the wood apple plant which would have caused its selection as the stock. Is that clear, student? So with that, I'll move on to the next part of the question. Part 5. The farmer cultivated in the farmland a garden pea plant which was rare in the area where his farmland is situated. So it is a garden pea plant which is rare in the area. So he cultivated that. That garden pea plant bears round seeds. A majority of the new pea plants grown from that garden pea plant bears round seeds, but the rest bears wrinkled seeds. Based on your knowledge in genetics, explain this phenomenon using the Punnett square. So here there are two characteristics you can see. One is round seed. Then there is the wrinkled seed. So now they have mentioned it is a rare plant. So in that area, there is no way a new characteristic can come from another garden pea plant. So it's not common. Only a few plants in his farmland are there. And there are round seeds. All the plants he planted had round seeds. But the new red generation had both round and wrinkled seeds. And that also, it is said that there are more round-seeded plants compared to the wrinkle-seeded plants. So, you are familiar with genetics. You all know the monohybrid cross. There what happens? Now, if we consider the two seeds, now you can remember students, if we say round and wrinkled seeds. Round seed, this has to be the dominant character. Whereas the wrinkle seed has to be the recessive character. So what happens? Normally when you have a monohybrid cross, initially we take the pure breed plants as the parents. Now here, since round seed is the dominant character, what is the gene combination, genotype? That is going to be capital R. Whereas wrinkle seed will be simple R. So in a Mendel's monohybrid cross, initially the parents will be capital R and simple R. From that you will get the first generation. What is going to be the first generation? Here I am going to directly write the first generation just because I am explaining this to you all. You all know from this you get the round seed, only one type of gamete. Here also one type of gamete. So F1 generation is going to be RR, all round seed. That is what the farmer planted. All are round seeds. But in his new generation, that is going to be the F2 generation, what will happen? He got a majority of round seed plants and a few wrinkle seed plants. So what is going to be the F2 generation? You can remember it will be capital R, capital R simple R is to capital R simple R and simple R. So all three will be round and this will be wrinkled. And you all know the ratio 3:1 ratio. So to get a higher number of round seeds and a few wrinkle seeds from all round seeded plants, you have to know that the initial genotype has to be a heterozygous condition. Capital R, simple R condition. Then only you will get both round and wrinkle seeds. If it was capital R only, he would have got all round seeded plants. But because his plants were heterozygous, capital R, simple R, in the new plants form, there were round seeded plants and wrinkle seeded plants. That is the information you have to understand. You don't have to write all this. This is for your understanding. Is that clear, students? So, based on this only, you need to answer the question. Here. Now, if you look at the question, you can see, based on your knowledge in genetics, explain this phenomenon using the Punnett square. So, here you all know the parent plants should be capital R, simple R. Round seed is capital R, wrinkle seed will be simple R, but the parent plants will be capital R, simple R, heterozygous. Then you need to show the Punnett square only for the new generation. So, you all know how to draw the Punnett square. What do we do here? You have to have a square. We divide it into smaller squares, and here you will have the male and female. You can also cross it like that. So, this side it's going to be the male plants, the genes, and the female plants, the genes. So, here what is it going to be? This is going to be capital R, this is going to be simple R. This is again capital R, simple R. So, these are the gametes from the male plant and the female plant, the gametes, or the male reproductive structure and the female reproductive structure gives the gametes. So, one is the dominant character, the other one is the recessive character. And when they combine, capital R and capital R will give you this. So, that is going to be a round seeded plant. Then here we have capital R and simple R. That is also round seeded. Although it's heterozygous, it's round seeded. Then here we have simple R, capital R, but when you write the capital R first and then simple R. Then these two, simple R, simple R. So, these three plants will be round seeded plants, and this is going to be the wrinkle seed plant. Is that okay, student? So, this is the Punnett square that you need to show. Is that okay? So, here if you again look at the question, the farmer cultivated in the farmland a garden pea plant which was rare in the area where his farmland is situated. So, there you have to remember why they say that it was rare. So, it's only his passion, the garden pea plant. So, there only the new generations have to form, and all the characters have to be within those plants. That garden pea plant bears round seeds. A majority of the new pea plants grown from that garden pea plant bears round seeds, but the rest bears wrinkle seeds. Is that clear? So, the parent has only round seeds, but the new generation has both round and wrinkle. So, then immediately you have to understand it should have been a heterozygous condition. Is that clear? So, based on your knowledge of genetics, explain this phenomenon using the Punnett square. So, here we have written round seed. Here, in addition to this, you can also mention that it is the dominant character and this is the recessive character. Then the parent plants are heterozygous like that. Then you have the Punnett square where you have the male and female gametes, capital R simple R and capital R simple R, and the new generation that is produced. Is that okay, student? So with that, I'll move on to the next part of the question. Here this is part B. Now the part A, it was a biology question. Now here you can see this is a physics based question. Now in part B of the second paper, question number 8 and 9, they are usually mixed from different types of lessons. So part B. In figure 1, A, B and C, D indicate two metal rails. So if you look at the figure, you can see A, B and C, D are two metal rails. You can see that. Then PQ is a conductor rod which can be slid on the two rails. So here you can see PQ is a metal rod that can be slid. It can move over the two metal rails. The resistance of the rails and the rod are negligibly small. So the resistance of both the rails and the rod are small. So that means there is no effect of resistance when the rod moves on the rails. That is why they have given that information. A uniform magnetic field is applied into the plane perpendicular to it on which the metal rails are placed. So here there is a uniform magnetic field. So you are familiar with this symbol, students. A round with a cross in the middle, that means there is something going into the plane. So here this is the board. So there is magnetic field going into the board. If it is the paper, into the paper. So a uniform magnetic field is applied into the plane perpendicular to it. Then you can see when the rod PQ is moved to right, an electric current is induced in it. So you have a magnetic field, there is a rod, the rod moves and an electric current is induced. That is due to the induced electromotive force. So what is this phenomenon? It is the electromagnetic induction. So you all know in electromagnetic induction, there should be a reflux in the magnetic field or a magnetic flux. When the magnet is stationary, there should be a movement of the conductor, or if the conductor is stationary, the magnet should move. So that it results in the magnetic flux that will induce an electromotive force which will make an electric current to flow. Then if you look at the diagram, so you can see the magnetic field is into the plane. Then there is the rod PQ. These are the rail A, B and C, D. And the rails are also completely connected. A, B, then C, D, they are connected by a conducting wire. And also you can see Y and W, they are diodes. You are familiar with this symbol. A triangle with a line, those are diodes. Now here you can see if current flows from D to B, this diode will light. Whereas here if current flows from A to C, diode Y will light. And here there is an arrow showing the movement of PQ towards BD. So in order to understand the direction of current flow, when PQ is moving perpendicular to the magnetic field and the PQ conductor itself is perpendicular to both the movement and the magnetic field, then what is the rule used to identify the direction of the current? You are familiar with the Fleming's right hand rule. Now in the Fleming's right hand rule, we need to have the three fingers perpendicular to each other. Thumb is the direction of the motion. This index finger is the direction of the magnetic field. And the middle finger is the direction of the current flow. So here we need to find the direction of the current flow. So what will happen? Now the magnetic field is into the plane. So the first index finger has to go into the plane. What is the movement of the direction of the movement of the rod? That is PQ. It's moving this way. You can see the arrow here. So the thumb has to point in that direction from A to B or C to D, that direction. And the magnetic field is inwards. So what will be the direction of the current flow? Now here you can see it will flow from Q to P. So if the current flows from Q to P. Again, to demonstrate the three fingers, motion, field and current. So field is inwards, motion is that way, so the current has to be up. Q to P. Then what will happen? When current flows from Q to P, if the current flows in this direction, QPB, can it go through W? No. Why? From the symbol you all know, W is forward bias from D to B. It will only allow the current to flow from D to B. That is the character or function of a diode. It allows the current to flow only in one direction because it's forward biased only in one direction, the PN junction diode. So here current cannot flow from W, through W. So it will not flow this way. This side, here no current. But this side you can see, if it is from QP, here you can see QPA, then if you look at Y, you can see it is forward biased in this direction, A to C. So current can flow this way. Current flows this way, this way, this way, here. So Y will allow the current to flow. But W will not allow the current to flow. So that is all what you can guess or infer from this particular diagram. You know the magnetic field, you know the direction of movement. So you can find the direction of current flow using the Fleming's right hand rule. Then you can see there are two diodes. So that means there is a possibility of the current flow from P towards B or A. But because of the diodes, the way the diodes are connected, current will only flow in the direction Q, P, A, Y, C. Not from P to B and towards D. That is not possible. Is that clear, student? So now that you have understood this question, the diagram given, we will answer the questions. The first part. Name the rule which can be used to decide the direction of the induced current in PQ. So like I said, Fleming's right hand rule. So you have to write Fleming's right hand rule. Now here students, you have to remember there is the left hand rule and the right hand rule. So you have to write it as right hand rule and also you have to say Fleming's right hand rule. The complete answer should be given. You can't just say Fleming's rule or you can't just say right hand rule. You have to write it as Fleming's right hand rule. Is that clear? So with that, the next part. Again, part B, the introduction, everything is given. We already understood the question. Part 2, according to the rule stated in 1 above, does the current flow from P to Q or from Q to P? So we understood that it flows from Q to P. So the answer is Q to P. Is that clear, student? So then, the next one, third one. Due to the induced current in PQ, only one of the LEDs labeled Y and W lights. So these are LEDs. The diagram shows the diodes, so they are LEDs. So then they can light. Only one of them lights. So that also we identified that LED Y will light. Why? That is the only diode that is forward biased in the direction of the current flow. W is not forward biased in the direction of the current flow. So what is the LED that lights? We already identified Y. You can write it as Y or LED Y. Then B part of the question, state the reason why the other LED does not light. So you can say W is not forward biased in the direction of the current flow. So that is what we need to write there. LED W is not forward biased in the direction of the current flow. So that is the answer for this question. I'm sure you all can understand. With that, the next part. So here, part 4. Figure 2 shows how a battery and a switch are connected between A and C after removing the 2 LEDs in figure 1. So in the previous figure, they have modified the activity. Here you can see, instead of the LED, students, there is a battery and a switch. Here you can see the battery and a switch. Now the switch is open, so current cannot flow. But if you close the switch, you can see this is the positive terminal, negative terminal. So the current will flow in this direction. A, P, then through the conductor, it will flow from P to Q, Q to C. So it will be like a complete circuit. Then what happens here? There is the magnetic field that is already there. A conductor placed in a magnetic field and the current flows through it perpendicular to the magnetic field. Then what will happen? It will be the magnetic effect of current where there will be a motion. A force will act on the conductor. There is magnetic field, there is current flowing through the conductor placed perpendicular to the magnetic field. Then there will be a force. You all know this is the opposite of electromagnetic induction. And to determine the direction of the force, you will use the Fleming's left-hand rule. Here also, thumb is the direction of the force, the index finger is the direction of the magnetic field, and the middle finger is the direction of the current flow. So, when the switch is closed, what will happen? Like I told you all, current will flow from A to P, Q, C. So, through the conductor, current will flow in the direction P to Q. Magnetic field is into the wall, into the plane, whereas the current flow is downwards. Then what is the direction of the force? It is from P towards B or A to B direction, towards that side or towards your right side. Is that clear? Current will flow from A, P, Q, C. So, through the conductor, it is going to be downwards, P to Q, and the field is into the plane. Therefore, the thumb points towards the right side, your right side. So, that will be the direction of movement of the rod PQ. Is that clear, student? So, then, if we look at the questions related to that, A part, state an observation made when the switch in the circuit is closed. Put on. You can see the rod PQ moving towards the right side. So, the rod PQ will move towards the right side. Is that clear, student? So then, the B part of the question, name a device made by using the phenomenon associated with the observation mentioned in part 4a above, that is this. So, when there is a magnetic field, a conductor is placed in the magnetic field, and when current flows through it, there is a force acting on it. Now, based on this principle or phenomenon, we have discussed different devices. You can remember the direct current motor. You supply direct current, there is rotation in the armature. With that, a load can be rotated. So, direct current motor. Then the loudspeaker, where the sound is given to the loudspeaker in the form of a varying electric current, and that is amplified. Because of the amplification of the cardboard cone, there is sound produced. So, there also we use this same phenomenon. You can write one of these answers. So, here name a device made by using the phenomenon associated with the observation mentioned in part 4a above. We can say DC motor, or you can write it as direct current motor, or you can say loudspeaker. loudspeaker. Is that okay? So that is the answer for this question. With that, I have actually completed question number 8. So here again you can see 20 marks. When you answer all the parts of the question number 8, part A, part B, in that all these sub-parts, in total you will get 20 marks if all the answers are correct. So with that, students, I'm going to end this chapter, and in the next chapter, I will discuss the last question of this paper 2.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.